Why do we call a neutral a neutral? This is for you guys that just keep saying, it's not a neutral conductor, it's just a grounded conductor. Yes, it is a grounded conductor. However, just grounding a conductor does not actually make it a neutral. Article 100 of the NEC has a definition for neutral conductor: the conductor connected to the neutral point of a system. Well, what's the neutral point? You can pause and read that whole thing. I'm not going to read it to you. But the important thing is actually this informational note. At the neutral point of the system, the vectorial sum of the nominal voltages from all other phases within that system that utilize a neutral with respect to the neutral point is 0. Well, what the crap does that mean? Let's take a look at a normal single-phase, split-phase system. I've shown this a million times, just like a normal residential service. You have your two legs exactly 180 degrees opposite each other. Now, remember in the previous video, I talked about how your voltage is constantly fluctuating up and down. So on this yellow sine wave, as your voltage is decreasing, at the same time on your blue sine wave, your voltage will be increasing. Now what this means, let me turn some cursors on here. So I can move these cursors. This one's on the yellow sine wave, you see. I'm just gonna just randomly put it right there. Any instant in time between these two sine waves, between the two legs, your instantaneous voltage, let me move this one for the blue one over here. So we'll put these exactly on top of each other. Our instantaneous voltage at any point along these sine waves is going to equal 0. You can see this by this AY value and the BY value. If you add those together, you're going to get 0. Now in three-phase, it's not as clear because you've got three sine waves that you're dealing with, but it's the exact same concept. So if you take any point, your instantaneous voltage, so let's say, let's see, I'm on the yellow sine wave now. So if we were to actually calculate this out, that point on this yellow sine wave, what that voltage is, and the voltage of the other two sine waves, you add all three together, it's gonna equal 0. Show this more clearly in a graphing app. So let's say, bam, right there. I just randomly paused it. Go ahead and add up 123.31, 39.69, and negative 163. Let me know what you get. Does any of that matter? Well, let's take a look at a three-phase Y system here. All three of these legs are tied together. Same with the three-phase delta, but that's another subject. So we tie all three of these together, and as we've just seen, the instantaneous voltage between all three legs, when you add them together, is going to equal 0. Just because we intentionally ground it does not change how it works. All three legs added together equals 0, aka neutral.